Let's go to prove the theorem of Pythagoras, and we'll try to go slowly, step by step. First step, we have a triangle. So the sum of all the internal angles should sum 180 degrees. Let's say that we have a particular triangle when one of the angles is 90 degrees. Let's say that this angle here is 90 degrees. So this is 90 degrees, so it means that if this angle is 30, this angle should be 60 because the sum should be 180. So the first idea that we develop on this task is to realize that every triangle, no matter the shape, no matter if it's a right triangle, the sum of the three internal angles should always sum 180 degrees. So we want to prove Pythagoras' theorem. And Pythagoras' theorem is only valid when you have right triangles. So in a right triangles, you have the longest side. In this picture, the longest side seems to me to be in front of the right angle. So it will be C. C is the hypotenuse, is the longest side. This we will call A, and this we will name B. And what we want to prove is that C squared will be equal A squared plus B squared if we have a right triangle. So now, how we will do the proof? So we are going to develop the proof step by step, and in every step we are going to develop an idea. So first step is to imagine that we can draw a line that is the height of the triangle from the right angle, from the vertex of the right angle to the hypotenuse. If we do this, we divide the big triangle into two triangles. So let's go to draw the two triangles. One triangle will be like this. One triangle will be like this. Will be like this. Okay. This is H, and this is also H. This is X, and this is X. And this is A. And what is the other triangle? And this is 30. This is 90 now. And we have to deduct what will be this angle. This angle is clear that it will be 60 because the sum have to be 180. So 60 is not a coincidence that 60 is here also. So this angle is equal to this angle. Now we divide the big triangle into two small triangles. So the second triangle will be like this, where this is 60. This is also H, this is V, and this is Y. And it's clear that C is equal X plus Y. Okay, so the first step is to imagine that we can divide the big triangle into two triangles. But now, on the second small triangle, we say, okay, this is 90. What angle is this one? This one should be 30. Oh, it's not a coincidence that 30 is here. Okay, so we have two triangles, and what we want to prove is Pythagoras' theorem that says c squared equals a squared plus b squared. What is the second step that we will do? The second step is to realize that here we have three triangles. The big one with 60, 30, and 90, the small one with 60, 30, and 90, and the other small one with 60, 30, and 90. So we have three triangles that are similar. So there must be a relation between the sides. So let's go to write the relation between the sides, and writing the relation between the sides, we can find the Pythagoras theorem. Let's go to do it. Then the step one is basically creating three similar triangles. Now we will say, because the three triangles are similar, there must be a relationship between the sides. So if I pay attention to the big one, all of them are right triangles. If I pay attention to the big one, I may pay attention to the relation between the hypotenuse and the side that is with the angle 30 in the middle, C and A. So now this relation should be the same one. If I pay attention to the small triangle, the relation should be the same one as the hypotenuse through the side that is on the 30 degree, means A divided by X. So C divided by X, A, it should be A divided by X. Okay, let's go to do the same relation comparing this big triangle with this triangle. Let's say that I divide C between B. So if I divide C, the hypotenuse divided by the other side, this should be the same relation in the small triangle. The hypotenuse is V and the side is Y. So this will be B divided by Y. So the step 2 will be a relation of proportionality between two similar triangles. So step 2, if two triangles are similar, it exists a K where the hypotenuse C is proportional to the hypotenuse of the small triangle of this one, K times, so the C is K times A. And the A is K times the A here on the big triangle is K times this side, X. So C divided by A is equal A divided by X. If doing the same thing with the big triangle and the small triangle, we will find the second relation. Of course, the K will be different K prime. Okay, this is the step 2. To use is the importance that when you have similar triangles, you have a factor K between the sides of the two triangles that you are considering. Now, the two relations that we have found is that C divided by A is equal A divided by X. C divided by B equal B divided by Y. So C multiplied by X is A squared. C multiplied by Y is V squared. So how we will find now Pythagoras theorem? Well, we will do a sum here. C that multiply X plus Y equal A squared plus V squared. And how we will find to find Pythagoras theorem with a remind that x plus y was c. So what it says here is that c squared equal a squared plus b squared. So this is the algebra that we use to find the Pythagoras theorem. So this proof have 3 steps. On the first step, we recognize 3 similar triangles. On the second step, we apply relations to find this relation. And on the third step, we do the algebra. And the algebra will say that c squared is equal a squared plus b squared if it is a right triangle, because if it's not a right triangle, what we have said is not true. Then the triangle must be a right triangle to take place the Pythagoras theorem. Okay, that's all.